Hi guys, welcome back to Business Statistics. This is the fourth and final video in our Module 8 learning. This is going to cover 8.3, testing hypothesis about a population proportion. Without any further ado, let's go ahead and get right into it. First of all, the sample size requirement for a test about a population proportion is what? Let's find that. We look at our grid here, and we can look under conditions and assumptions for 8.3, testing a hypothesis about a population proportion, conditions, assumptions. That is NP is greater than 5, and N times 1 minus P is greater than 5. That might mean nothing to you at this point. That's fine, but that's just the rule, so go ahead and write it down. Commonly used notation for the population proportion, that's this. 8.3 is our Z data value right here. Okay. And then commonly used notation and formula for test statistic are effectively the same thing. Okay. So population proportion, we've worked with this already. This was something that we worked with in Module 7 when we did confidence intervals, so you should be very familiar with that. And this is essentially, in layman's terms, this is when we're finding, when we're concerned with one characteristic of a population, right? So the easiest way to think about this is like voting, when somebody has an opinion on something. So they feel a yes or a no. It's a very binary thing. So it's sort of a success and a failure. It kind of reminds you of binomial in that regard. It's a success failure kind of thing. It's a vote yes, a vote no, a does have this quality, doesn't have this quality sort of thing. Okay, so this, we're not going to have a mean. The characteristic that we're always going to be concerned about is what would be known as rho or P, population proportion. We're going to be using P hat, which is known as the sample proportion. So that's kind of akin to X bar being the sample mean, sample proportion, P hat here. So I mean, I know we've covered this already, but just wanted to kind of remind you of that. Okay, so without any further ado, let's go ahead and get into the problem. Example 5, a one-tailed test. So again, just over the moon that I left one-tailed test in there. But yeah, I mean, it's fairly easy to see why we do that, and I'll explain that during the problem, just like I have been, okay? All right, in 2008, 46% of business owners gave a holiday gift to their employees. Based on a sample of 60 business owners, a 2009 survey indicated that 21 business owners provided a holiday gift to their employees. Would you conclude that the population proportion of business owners providing holiday gifts in 2009 decreased from the 2008 level? Use a statistical hypothesis test to determine this. Use a 1% significance level. All right, so we're going to kind of do what we did, and we're going to like write down what we have kind of before we get started. So we have P, or P naught as it's called. So P naught, rho, anything like that you want to call it. Basically the status quo is 0.46. All right. That is not a 9. I don't know why my pen did that, but 0.46. Based on a sample of 60 business owners, so we have an N equal to 60. Indicated that 21 of those business owners provided holiday gifts. So X equal to 21. And then it also gives us a significance level of 0.01 to use in the test. And that's about all that we have. The only thing that I'm going to go ahead and do beforehand, and you'll see why later on, is I'm going to go ahead and calculate P hat. So normally we would have like an X bar or sample mean, but we know from prior knowledge and from chapter or module 7 stuff that P hat is just equal to X kind of being the number of successes or possessors of the trait or positively identified things, X divided by N. Okay, and N being the sample size, obviously. So we know that then P hat is equal to 21 over 60, which is equal to 0.35. Okay. Cool, cool. All right, so this is going to kind of be boxed off, and that's that. So now we're going to get into our hypothesis test. So we have an H0 and an HA as always. And what is this going to be about? This is going to be about P, our population proportion, and then there's going to be some operator, and then we're going to be drawing some conclusion about the status quo, about this 0.46. And so let's read this again. Would you conclude that the population proportion of business owners providing holiday gifts decreased from 2008? Okay, so did it go down? So that's our suspicion, right? And so then thus conversely, H0 is that. So number 2, what's our alpha level? Well, our alpha level is given to us in the problem of 0.01. Number 3, hey, what test are we using? Okay, well the good thing is unlike what we just did, this test we only have one formula for. So if we are looking at population proportion, right, if we can see in step 1 that we are doing population proportion, we only have one thing. We don't have to consider like do we have a sigma or do we have an S or anything like that. So this is just going to be called z-test about a population proportion. Okay, not a population mean, population proportion. And our formula is just going to be z is equal to p hat minus p divided by the square root of p times 1 minus p divided by n. Okay, so that's that. So 4, we're going to draw our curve. Okay. And yeah, what kind of curve is this? Well, it's a z-curve, right? Because we're using the z distribution. We're using the z-test. All right, so we still are working with like this normal kind of bell curve. And then we want to know, okay, well, where is our rejection region? Well, we look up here into step 1. We can see that HA is pointing to the left. So our rejection region is right here. How big is our rejection region? We look at step 2. Alpha is 0.01. So our rejection region is 0.01. So our fail to reject region is 0.99. Okay. And what z-value do we use? Okay. Z-value of 0.01. Which is the z-value where 0.01 of the area is to the left of this. So our z-crit is going to be the z-value of 0.01, which happens to be, I actually know that it happens to be 2.33, but let's look and find that. I know that because that's one of those numbers that we memorized, right? That was the one for the 98% confidence interval. And we know that it's the one using the 98% confidence interval and not the 99%. Right? Because when we had a 98% confidence interval, we had a tail of 0.01 on one side and a tail of 0.01 on the other side. So this is going to be the same line in the sand that would have helped us draw a 98% confidence interval because it leaves a tail of 0.01 on the left-hand side. Okay, but if we want to look at it just more I guess nuts and bolts as opposed to memorizing things, we're going to look at our z-table and we're just going to find the point within the table where 0.01 of the probability resides to the left of it. Okay, so we look down here, march down, 0.01, 0.01, there it is. So we passed it, so we go to the right, 0.0099, and we can see negative 2.33. So go back here, and yes, I did forget to put the negative in there. So yes, negative 2.33. So we want to establish our rejection region. So we say reject if z calc is less than negative 2.33, or z crit of negative 2.33. Okay. So we go and we do step 5. So step 5 is just, hey, plug in the stuff into the formula from step 3. And let's do that. So we'll say z calc is equal to p hat, which is 0.35, minus p, which is 0.46, divided by the square root of 0.46 times 0.54, 0.54 being 1 minus 0.46, all over the square root of n, or all over n, I should say, 60. Okay, we run those numbers, and we're going to get negative 1.719. Okay, so where does that fall? So there's the middle there. So that's going to fall somewhere like here-ish, right? So it's not quite there. So this is fail to reject because zcalc is greater than zcrit, which is to say negative 1.719 is greater than negative 2.33. Okay, and then this would be, we don't have significant evidence to suggest that the amount of business owners who bought their employees gifts has decreased since 2008 for this 2009 data. Okay, that's that. Guys, let me know if you have questions on that. I'm going to move on to the next example of a two-tailed test. According to the University of Nevada Center for Logistics Management, 6% of all merchandise sold in the U.S. gets returned. Kind of sounds like a status quo, right? A Houston department store sampled 80 items sold in January and found that 12 of the items were returned. Use a statistical hypothesis test at the 5% level of significance to determine if the proportion of returns at the Houston store is different from the returns for the nation as a whole. Okay, so let's do what we do here. So let's go ahead and write down what we know. So we have this P of 0.06 or 6%. That's kind of our status quo. It's P or P naught, however you want to write it. What else do we have? We have an N, sample size of 80. X would be the positive result of that sample size, 12. And then we have an alpha level of 0.05. And then furthermore, let's calculate our p hat because we know p hat is equal to x over n. So p hat is 12 over 80, which is equal to 0.15. Okay, so we just rope that off a little bit and then get into our problem. H naught and HA. Okay, we know that it's going to be about the population proportion. We know what our status quo is, 0.06. So this is asking us to determine what? So we know, given the name of the problem, that it's a two-tailed test. But how do we know, given what's in the problem? Use a statistical hypothesis test at 5% level of significance to determine if the proportion of returns at the Houston store is different from the returns for the nation as a whole. It doesn't say is greater than. It doesn't say is less than. It doesn't say is more. Right? It doesn't say anything like that. It says is different. That says not equal to, different. Okay? And then thus H naught is just equal to, what is our significance level? What is our alpha level? 0.05. 3. We only have one formula for this, right? Whenever we're working with a population proportion, we just have the one formula. So that would be z-test about a population proportion, okay, and that is just z is equal to p hat minus p divided by p times 1 minus p all over n. It's the same formula that we just used on the other problem. Okay, and then, so that is that. So then 4 is, hey, let's draw our picture and establish our rejection regions. Okay. And what do we got here? So we want to know, do we have a one-tailed or two-tailed? We know from this problem that it's two-tailed because it's equals, not equals. So we draw on our two tails. How big are the tails? Well, the whole area of the tails has to be alpha, right? So we know that these are going to be alpha half, 0.025. Okay, and what else? So this is our FTR, this is our RR. Oh, and we know that we're working with Z values here, right? So what are our Z values? So this is going to be our Z crit negative. This is our Z crit positive, right? And we know that because with our Z values of 0.025, we know that this is going to be a negative 1.96. At least I do. Right, I remember this. You guys can get more practice and go and look at the table. With these, this is one of those values that we've memorized. Okay, so this is to say reject if zcalc is less than z crit negative, or reject if z calc is greater than z crit positive of negative 1.96 or positive 1.96. Okay, so what do we do next? We have to calculate what is our z calc. Z calc is equal to this formula, but with us plugging in everything. So 0.15 minus 0.06 divided by 0.06 times 0.94 all over the size of the sample, which is that. We run those numbers and we get a 3.33. Okay, so 3.33 falls where? Well, it looks like this thing is going to fall somewhere over here, right? It's positive. It's greater than our z-crit positive. So, step 6, reject. Because z-calc is greater than z-crit positive. Furthermore, to say 3.3 is greater than 1.96. And then thus, our step 7, turning it into a managerial conclusion or a business solution, or put it in layman's terms to put it back in terms of the problem, is to say that we do have significant evidence to suggest that the proportion of returns at the Houston store is different than the returns for the nation as a whole. All right, so we can see that it's actually probably more than the nation as a whole, but in terms of the problem that we set out to solve, we were just looking at equals, not equals. Okay, guys, let me know if you have questions on this. Glad to keep this video a little bit shorter. I know I buzzed through everything, but you guys have the good option, because it's an online class, to be able to pause and rewind and all that stuff. Also, ask me questions. I'll try to get to them as soon as possible. I'm surprised my voice held up. I'm going to wait, I think, till later tonight or tomorrow to post the review for 8. And I'm probably going to wait then similarly to post the problems for 9 too. But please let me know if you have questions. Yeah, more to come. All right, thanks guys. Bye.